Hi everyone, today we're going to study inverse matrices. In this video, we're going to calculate the inverse of a 2 by 2 matrix. If capital A is a square matrix of order n, and if there exists another square matrix capital B of the same order n, such that A times B is equal to B times A is equal to capital I. This is the identity matrix. Then capital B is called the inverse matrix of capital A, and it is denoted by A with an exponent -1. We read this as A inverse. In this case, A is said to be invertible. There are some notes here. Number 1, a rectangular matrix does not possess inverse matrix, since for the products BA and AB to be defined and to be equal, it is necessary that the matrices A and B should be square matrices of the same order. Point number 2, if capital B is the inverse of capital A, then capital A is also the inverse of capital B. A square matrix capital A which has no inverse, that means determinant of A equals 0, is called a singular matrix. Only non-singular matrices have inverses. Now let us discuss the inverse of a 2 by 2 matrix. Let capital A equals the square matrix A, B, C, D elements respectively be a 2 by 2 matrix with determinant of A not equal to 0. Then the A inverse, this is our symbol, this is equal to 1 over determinant of A multiplied by this matrix D, negative B, negative C, A. When we compare this with our original matrix A, look at the main diagonal. The elements AD are interchanged in here. So D comes here and the A comes here. For the elements of the secondary diagonal, we will change the sign. So we have here negative B and this one here is negative C. Take note, determinant of A is equal to AD minus BC. This is the formula for the inverse of a 2 by 2 matrix. Example 1. Find the inverse of the matrix A equals elements 2, 4, negative 3, 1 respectively. We write here the formula, then let us evaluate and substitute the corresponding values. The determinant of A becomes 2 times 1 is 2 minus negative 3 times 4, negative 12. 2, 1 becomes 1, 2. Then we interchange the signs of the elements of the secondary diagonals. The 4 here becomes negative 4 here. The negative 3 becomes positive 3. Now we simplify the determinant. 2 minus negative 12 is positive 14. This fraction outside, we will multiply to each element of the matrix. So we have now 1 over 14, negative 4 over 14, 3 over 14, 2 over 14. Then we simplify some fractions. This negative 4 over 14 will be negative 2 over 7. The 2 over 14 will be 1 over 7. This is the inverse. Example 2. Find, if possible, the inverse of the matrix A equals the elements 3, 2, 6, 4, respectively. We write our formula for the inverse. We can see here that in this case, the determinant of the matrix is 0. To show that, we have this 3 times 4 is 12 minus 6 times 2 is 12, and this 12 minus 12 is 0. That means the matrix is singular and no inverse exists. Here are the properties of inverse matrix. Let capital A and capital B be n by n matrices, with determinant of A not equal to 0 and determinant of B not equal to 0. Number 1, the inverse of the product AB is equal to the inverse of B times inverse of A. Number 2, the inverse of the inverse of A is equal to A. I hope you learned something from this video. See you again next time.